Engineering organized this webinar as part of the Gandhi Week. First of all, let me welcome the resource person Mr. Mony Bernard, to this session. Thank you, sir, for showing your great support to Christ family. Next, let me welcome our dynamic Executive Director for the John Palekara, Joint Director for the Joy Paipali, Principal Dr. Sajiv John, Vice Principal Dr. Vidi John, our Chief Mentor Prem Kumar, Department HOD Professor Benny KK, all other department faculties and all the participants to this webinar. I would like to thank all the dignitaries and participants for taking the time out of your heavy schedule and marking these lessons. Hearty welcome on behalf of Christ. So happy to have you on this webinar. The function of prayer is not to influence God, but rather to change the nature of one who prays. Let's begin the session with a silent prayer.
Now I welcome Reverend Father John Palekara for his felicitation. Now I welcome Reverend Father John Palekara for his felicitation.
Respected Mony Bernard, the chief guest and the resource person of today's webinar, respected Father Joy, respected Principal Dr. Sajiv John, Vice Principal Dr. Vidi John, Professor Prem Kumar Sir, and respected HOD of Electrical and Electronics Department, Sri Benny, and respected faculty members of other faculty and my young engineers. First of all, I just want to thank Mr. Mony Bernard to come over and to have that disposition to inspire the young engineers of Christ College of Engineering. As we know, he is a close friend of Nitin KS, our faculty member, and they both did their graduation together from Idukki Government Engineering College. Then he moved to Argentina, the land of football, and he made his master's from Argentina. And he got that generous heart to share his exposure and experience with young engineers of Christ College of Engineering. Thank you so, sir, for your benevolent and generosity to come over and to share your vast experience with our young engineers. And we know Earth is very precious. We cannot extend the land and the facilities of Earth. And we can make use for our life, but we should be very cautious, and we should be always use for our purpose. Manage the habitat Earth. We should be always, we should not exploit the land and the facilities that is offered by God Almighty. But we should be very careful to use it in an optimum way for the benefit of human beings. And from the inspiring talk by Mr. Mony Bernard, we'll get great insights, and let us join together to make our Earth a beautiful habitat to live for. And again, I congratulate Electrical and Electronics Department of Christ Engineering College initiative, and it is absolutely he only took the initiative, and I congratulate all the student engineers of our college for making such a wonderful initiative. And I also congratulate all the faculty members of Electrical and Electronics Department of Christ Engineering College. And again, I congratulate Nitin sir with his close associate to make him available for such an exposure. Thank you. And I again gratefully acknowledge the commitment and the readiness to come and share your valuable time with the Young Engineers of Christ College, Mony sir. And we are always welcome you. And thank you so much. And have a wonderful time to everybody. Thank you. May God bless you.
Thank you, Father, for your beautiful and vivacious words. So now, let me give a brief intro about Christ College of Engineering in Nalakkada. It's one of the top-ranked engineering college in Kerala, established in 2015 by CMI congregation. Here we have freedom with responsibility, and all the pass-out batches from CC has acquired great morals and values in their life. We are achieving great summits and climbing the ladder of success with the help of energetic Christ family members.
Thank you, Rajeshwari. Now, for the dignitaries and participants to know more about our resource person. Mr. Mony Bernard pursued his BTech degree in Electrical and Electronics Engineering from Government Engineering College, Idiki. He pursued his MS from National Technological University, Argentina. Now, he is currently working as a project engineer in Veolia Environmental Service. Hearty welcome, Mr. Boni Bernard, to Christ family. Let's begin the session. So, please.
Thank you. And today I'm really happy to this occasion. I don't get much words to express my thanks. And with this webinar with Christ College, I hereby take a minute to thank Father John Paliagra and John Director and Father Joy Payapili, Principal, and Dr. Saji John Sir, Vice Principal V.D. John Sir, and the electrical HOD, electrical and electronic division HOD, Professor Bindi sir, and my beloved friend and your professor, Mr. Nitin K. sir, and all students and all the faculty and non-faculty members and their students, and some of my friends who joined from Argentina also. And today, we all know that. And there's a saying I remember this time: cleanliness is next to godliness. We all know that. And this month, we all know our Father of Nation was born, and he had a great vision about a clean society and sustainability. And today we are going to discuss about a very interesting topic, like landfill management. And let us come to the topic. What is a landfill, and what is the distinction between a landfill and a sanitary landfill, and its constructional details, and future sustainability and aesthetic ideas. And let us come to the slides, I think so. And this is our topic, the sanitary landfill management and sustainable energy. And what is a landfill? Maybe some of the guys inside in this group maybe have some idea about what is a landfill. It is a process used for the final disposition of a solid waste on earth, particularly domestic waste. It is the simplest discharge of waste on land without protective measures for the environment or public health. There is what is a landfill? Landfill and sanitary landfill is somewhat different actually. And landfill is it's a final disposition of solid waste in earth, but there is no much controlling measures. We can see that there is a lot of places in India that we can see a lot of waste. Actually, they don't know actually how to manage waste, and that's a fully a mess actually comes around. And in this simple discharge of waste onto the land without protective measures, and it will cause a harmful environmental issues actually, and health also. So you can see in this picture, and this is a landfill without proper measure. There is a damp hill, like you can see kind of messy manner. You can see a lot of waste, and there is no distinction of all this waste, and we don't know what kind of waste actually in it. And What is a landfill and what is a sanitary landfill? A sanitary landfill technically is a clean solution of final disposition of urban as well as industrial solid waste, and it does not cause damage or risk to health. Moreover, it minimizes and disable environmental impacts. And it's based on engineering criteria and specific operational standards, allow the safe confinement of things, environmental contamination, and public health protection. You all heard about me. What is a landfill? And you guys get some clear idea. A sanitary landfill is a confined technology, like what we call. It's a clean solution of the final disposition of urban as well as industrial solid waste. As I know that I am an engineer from BLU in the services, and I have a clear idea of how to manage all these things. And let's come to the slides. We can see a lot more specific about this topic. And it is based on a sanitary landfill is totally based on engineering criteria, and there is a lot of proper coordination of three kind of engineers, like what we call environmental engineer, a civil engineer, and geotechnical engineer. And it's a combined operation, combined a lot of details actually comes in this topic. And the idea is the safe confinement of all the waste from the land without any cost or health, and humans and environment both are very important. The human health and environment. In this time, we are actually more concentrated than our environment and how we have to protect. As an environmental engineer, I know that and how we have to be protect our environment. Like this technology, like landfill, sanitary landfill, we can we can see a lot of a tremendous change for the land the waste management. The sanitary landfill cross section we can compare the previous picture and coming to this picture. And there's a cross section of a landfill. Actually, we can see a lot of details in this picture. This is a cross section, and we can see the safe confinement of waste and garbage with different layers, and there is a lot of pipelines inside. I will explain. And this is a cross section. Actually, you guys have to remember transformation of a landfill into a sanitary landfill, and what kind of things actually we really need to consider about while transforming a landfill and a sanitary landfill. Technical guidelines, health problems, and environmental problems. These are two important things actually we can consider at this time. Those that affect directly to the public health and environment. We need to protect our human health. First of all, we consider sanitary landfill. We need to consider the health problems, how we have to reduce all the health problems and the issues of environmental problems also. Those that affect directly to the environment or interact to the public health. You know that if there are any problem that cause our environment, that will cause ourselves also. So we need to reduce all these problems while we prepare to convert a sanitary landfill. Sanitary problems. Sanitary problems. It's based on how we have to be make healthy, how to manage all these things like a sanitization, what kind of sanitization, what we adopt in this technology. Movement and confirmation of the mass of solid waste, and eliminate the fire and smoke, delimitation of area, cleaning the general area, etc. And movement and confirmation of the mass of solid. We need to consider about we cannot distribute the waste to any other places. We need to manage into a specific place actually, and we need to continuous checking is necessary because different kind of waste actually occur in this time, and to prevent the fire and smoke or what exists thereby campaign. Because in waste we can see a lot of different elements maybe that will cause some smoke or fire, etc. There may have chances, right? And delimitation of area. Delimitation means what we call we actually are doing this thing in this landfill for a specific place. We need to choose the zone. We need to make a certain space for safest confinement of all these waste. So delimitation is very important. Cleaning the general area. It's a landfill basically comes for a huge area. Maybe we need 50 acres, 60 acres, etc. It depends upon the size of the land, maybe, and all these places, all the inside the landfill and the surface places also we need to clean, and this is very important for the safety operation. Environmental problems. What we really need to some environmental aspects here comes like surface drainage, separate percolated water leach. What we call drainage, and like in a landfill, we need to consider the first point. We need to make sure the proper drainage system is inside the landfill area and outside. Now outside we need a collection system of different pipes and proper drainage. Otherwise, when there occur rain and rainfall, etc., that will comes a lot of huge amount of water come to the landfill area, and that will cause excess pressure, excess flood, and water pressure inside the landfill. That will cause the breakdown of the landfill also, and this is a very harmful thing. So we need to consider about a proper drainage system in the landfill. Landfill site, both external and inside the landfill also. Inside the landfill, I will explain environmental problems. Other environmental problem we can consider that when the waste comes to generate inside the landfill, there may cause a lot of gases, like due to the microorganisms, like you guys all hear about a lot of those microorganisms come into contact with the waste, and there is a degeneration or decomposition of the waste, and there occur a lot of different gases, like what we call carbon dioxide, carbon monoxide, H2S, and methane gas also. And we have some solution for sustainable form of energy by considering a landfill management, and I will explain that part in the next slides, I think. Landfill gases. Landfill gases is one of the most important thing that occurs, and this is one of the part of our sustainable energy, because of in a landfill we have to manage. Landfill is a big project actually. It may comes around 20 years, maybe 15 years and more. When it finalizes also, there is a proper management is needed for a landfill actually. And landfill gases consist of there may occur methane gas and carbon dioxide, and we need to collect all these gas system, and due to some pipes actually installed inside the landfill system, and these gases we can use for energy management, like electricity, the production of electricity. Then it's resulting in anaerobic decomposition. Actually, the gas starts occurring in the landfill due to the anaerobic decomposition. Anaerobic decomposition mainly, you know that there is this certain process of a bacterial action, like microorganisms. Anaerobic decomposition mainly they have 4 steps that will cause the hydrolysis, acidogenesis, like acetogenesis and methanogenesis. In the final stage, we can that may produce methane. Methane is a very it's a gas, we all know that, for our daily cooking process or something like that. But methane has a very harmful effect to our environment. It's a greenhouse gas, and it has 84 times more harmful than carbon dioxide. So for a certain landfill, like a very small landfill management, this gas we don't have to collect, but rather we like some flares, like burning. I will explain to them in the slides. And small landfill management, we don't know. We don't really need for the collection of methane and for the electricity production. But in bigger landfills, we can see all these methanes have and we collect and use for electricity production. A typical landfill gas collection system and energy plan works. Actually, you guys had to see those two pictures here in the left side. How we have to manage it's inside the landfill, and this diagram this diagram of a particular landfill, there is a lot of pipelines inside, and there is a lot of waste actually managed like cells. You guys have to see some trapezoidal spaces like that. Is all wastes are layered and structured like a very proper manner, and there is a lot of pipes, and there is a gas collecting perforations actually you guys had to see in this picture, and there is a flare also, and there is a leachate collection plant also, you can see that. And the right side picture is one of the one of the gas pipe we had to be we can control the gas and the flow of gas, etc. And this is one of the monitoring sustain. This is one of the monitoring. There is a proper adequate monitoring necessary for all the gas and etc. Because of when we consider when we construct landfill, and there is a lot of environmental problems. So we need to check every week or every month, etc. Thereby, there is gas wells, there is monitoring gas wells, and there is water exit we call a water monitoring system also. And the efficient engineers come every month or every two times per month. I know exactly is there any problem or any harm due to this landfill system also, because of the front side of the landfill and the extreme end, and we consider two monitoring system for is there any problem inside the water tables of the landfill, because of there occurs a lot of harmful leachate liquids. Actually, I will come to that point. Okay, environmental problems. What is a leachate actually? A leachate is a liquid generated by decomposition of the waste due to microorganisms, due to infiltration of the water. The infiltration of when it comes rain, and there is a lot of water comes to the landfill base, and this is a very contaminated water. Like it's dark color, very dark color, and it has a BOD rate somewhat higher, and it has a great pH rate also. So it's particularly acidic, and this water. We have some system at the base of the landfill, and we have some collection pipes and etc. I will explain to the next slides. And you guys have to see in this left side of the picture, there is a water actually ooze into the landfill, and there is a collection system there is a pool system, and there is a water treatment plant. I come to the next plant, and that will control the pH and the BOD, biochemical oxygen demand, and then it draws to the kind of a lagoons or the river, etc. You can manage it, but there is no harm to the environment. This is one of the pool, that leachate collection pool. Actually, you can see in this right side of the picture. And what is leachate? What is a leachate? I already explained what is a leachate. Leachate is a liquid generated by the decomposition of the waste of microorganisms and due to the infiltration of rainwater. You guys all know the waste will decompose or degenerate, and due to the combined action of microorganisms. That's a grace actually in our environment. Without microorganisms, you can imagine how all these waste where it comes or goes or something like, etc. And leachate can migrate into underlying water, resulting in contamination. This leached water, it's a very harmful water, and if we have any permission to enter to the groundwater or our ground, that will cause a serious contamination to our environment. And leachate can contain many different chemicals, and depending on the composition of the solid waste. Most probably, we are manage all these waste for urban waste and industrial waste. All are distinguished. It depends upon the landfill, and we have different landfill management areas for our urban part, or what we call that the industrial part. It depends upon the landfill and management, etc. And these leaches can contain many different chemicals. and maybe all these chemicals we don't know how it combines and what kind of this is a leachate collection system. There is a different kind of a leachate collection system. We can while the construction. This is the construction aspect. Actually, we can see in this picture, and you can see the base of the landfill. Now we can construct different manner. What I was actually managing landfill here in Saturday. There is a city, small town near to me. There is a gravity of like a 60 centimeter, 60 centimeter, I think so, for the slides, like slopes at the base. So when the wastewater, like leachate water, comes, it will ooze, and by the action of gravitational force, and so we can collect. And there is a lot of pipes actually at the base of the system, and these pipes they collect all these. This is primary pipes actually, and all these primary pipes it takes down all this water and takes out for the action of secondary pipes, and there is a lot of pumps, submerged pumps, underwater submerged pumps also. And this is mainly gravitational sawtooth and fishbone manner. We can see in the right side of the picture, there is a sawtooth manner, actually construct at the base of the landfill. So in this pattern, it's very easy to use out and separate all this leachate water to the collecting pipes and taken outside. And it's a very good engineering side of civil engineers. And we can see a lot of pipes also. There is a cross section of a pipe we can see in this picture, the bottom side. And all these pipes has some perforations, some holes, and all these holes, all the water is very easy to comes inside to the pipes, and we can take an out. And leachate collection system and how the plant works. It's a typical picture. We can identify how it works actually. When comes rain, there comes a lot of leachate, or there produce a lot of water actually, and all these pipes are how it works, and taking out all this leachate and to the water treatment plant. And what exactly the action of water treatment plant? You guys know that, and how the water treatment process or something like that. A kind of chlorination and different process. One of my friends, those who joined in this class, Hernan B, is a professor. I know very well about that. Project elaboration. Project elaboration is mainly a remediation of the solid waste. You know that and the landfill is basically for remediation of solid waste, the transformation of the landfill into sanitary landfill. And these are the 4 steps. Actually, we need to consider the project elaboration. Remediation of the solid waste, transformation of the landfill into a sanitary landfill, operation of the sanitary landfill, and closure of the sanitary landfill. The operation, it's a combined project. Actually, I already mentioned so we need a lot of discussion before starting a project, because of its we need to consider all the aspects, all the environmental and health aspects, and how we have to tackle all these small details, something like that. A remediation of the landfill. Remediation mainly a discipline and regularize solid waste. We need a complete discipline. It's a disciplinary action actually. We cannot do it like a messy, because of there is a lot of equipments and human activities actually surrounding this landfill area. The formation of solid waste cells, because of discipline, this disciplinary point, we can see that formation of solid waste cells. We can I will explain later what exactly a waste cell, a delimitation of the operation area, because in a landfill there is a limitation actually. We need to take it out for some machinery is to confine for all this waste to the proper manner. A covering of solid waste cells, then if there be complete for it's a daily process. Maybe we will extend 10 meter or 20 meter, etc. Depends upon the landfill and depends upon the trucks actually comes with waste, etc. We have some daily operational standards, and maybe 10 meter of advancement of length or something like that. We can operate daily basis, and we have a proper action of machineries as well as a human disciplinary action. A covering of solid waste cells. once we finished daily waste coverage, daily waste managing, there will come some 15 centimeter or 20 centimeter, or what we call a kind of a special kind of clay or soil what we removed from the landfill. We can use that for a covering of each and every landfill cell. And drainage, surface water drainage during rain and disposal of gases, leachate. And I already explained about what exactly the drainage and how it comes for the action. And disposal of the rainwater, we are very cautious about rainwater. When rain comes, we need a proper drain. Otherwise, it will interact with our landfill area, and the water pressure increase, and there will be a disallocation of the waste, and that will cause a serious problem. It will take time to recover. So we need a proper drainage system and disposal of gases and leachate also. Disposal of gas, I already told that and told you. And there is a lot of collection tanks, collection pipes of the gas collection pipes, and it can take out all this methane gas, carbon dioxide, etc. And then leach it also. Treatment of the base. Treatment of the base, it's a very important thing. Treatment of the base. The base of the landfill, we need a proper protection. Because of it's a very important part we need to consider. If there comes permeable with the leachate inside to the water table, we know that we have a lot of different water tables, and that will contaminate, and that will cause a serious trouble. So we need to protect and need to consider very important waterproofing system. This is the waterproofing system actually comes around for a landfill, and this is in this picture we can see different layers. Different layers. The base, and the base we need to consider, like I'll explain one of two. Okay, and this is one of the project actually I done in Surrey, and before constructing a landfill, we need a compaction. We need a proper compaction of this land inside the landfill, what we are constructing the landfill here. Compaction and geobentonate. This is a special kind of clay actually we are using for compaction. This compaction, it's maybe 1 feet, 80 centimeter. In this, it's okay. It's okay. 50 centimeters. It's okay. But in this picture, in this project, we are actually using 60 centimeter of land, make it impermeable, like a special kind of clay, geobentonate, what we call. And then this is one of the greatest thing actually we have done. In this left side of the picture, you can see that this is a geobentonate clay. Actually, we are confined with compaction and very. This is a great protection. It's a secondary protection, but we have this is a primary protection, and that becomes the secondary protection. Above this land, we are constructing. We are using geomat. Geomat, what we call, it's a geobentonate also, and it acts like a bed. It's a cushion, like inside this yellow colored mat, there is a geobentonate layer, and you know that this when the water comes to contact with this geobentonate mat, it acts like a plug. It just swollen and act like a cement structure or something like that. So there is no way to come inside water, and there is a two-layer of protection that becomes another layers also. And this is what we call HDPE. HDP, what we call a high density polyethylene. It's a geomembrane. It's a geomembrane, and it's a plastic, and it's not a normal plastic. It's a high density, and it will like a higher protection. And all this pattern in the right side of the picture, there is a welding machine. There is a geobentonate HDPE high density polyethylene welding machine. And this is using for a high fusion technique, a high temperature process actually, and we can use it like a one single coverage at the base of the land. And above that, that will comes geotextile. Geotextile is a fabric, and it will allow all this leached water very smoothly to the base. And this is one of the HDPA, the high density polyethylene. Also, it's a fabric. It's a cloth like thing actually, and it's also we need a proper welding with the temperature fusion technique. And above that, there will come round stones. These round stones that will act as a filtering manner of all this leached water will comes very easily to the base of the landfill by these round stones. So we are using that. And okay. Uh, about this, what we call these round stones will comes all this waste, the garbage, etc. Transformation of the sanitary landfill. Transformation of the sanitary landfill. Access. Okay, we just not only for we are considering the landfills area. We have an entire structure. This is a combined project. There is a lot of different things actually comes into a landfill because of that there comes a lot of different trucks from the urban area comes with waste, and there is an entrance, what we call there is there we can see. Okay, there is an entrance, and there is a security area, and there is a balance. Actually, what we call it's a weighing machine. When the truck will come, they have some specific manifestation for what kind of a waste where it will come, and that the truck is allowed for this particular landfill, etc. And before the manifestation, we are checking for the permission. When once it per, when it get the permission, and there's a laboratory near to the installation area, and there is an engineering department also. And the laboratory technician will takes out the samples of the waste, what kind of a waste, and we have some manifestation what kind of a waste actually going to manage. And we don't allow for dangerous waste, etc. Batteries, dangerous waste like e-waste, and what we call um, paints, solvents, etc. And after the permission, they have to manage. There is a proper base. We can see that there is a proper passage they have already constructed how to manage in a safety manner without any disturbance inside. Okay, sanitary landfill transformation. Well, geometric design for the formation of the cells, crane projects, project operation daily, monthly, preparation of the proper surface treatment for the filling cover. Okay, I already mentioned these things. Oh, okay. In this topic, in this particular slide, we can see that a geometric design of the landfill is very important. We need to consider we cannot operate a landfill in a very closest place because of we need to consider both the human health and environment. So we need to particularly select a landfill place. It's a little apart from the population, and we need to select the zone, and we have a combined process of study about the geotechnical engineer and civil engineer and environmental engineer, those who check all the elements of landfill, and there will come any problem to the nearby places, etc. We need to construct a landfill apart from a airport and a human population for a particular distance, etc., and all these things. And how we have to be operate project operation, daily, monthly, sanitary landfill operation, preparation of the proper surface treatment of the filling cover. Okay, and it's a basic things actually. I already explained. Landfill cells construction methods. Landfill cells construction method. We can see that there is a three different process for the construction of a landfill: trenching, ramping, and leveling. In the first picture, you can see that those technicians preparing for for a trench. They are actually making a trench, and this trench have a depends upon all these measurements, etc. And they have to make it. The second, ramping. The proper ramping is very important, and because of without the ramping, they may cause disallocation of the waste, and maybe future they will come to blast or etc. And proper leveling. Leveling I already explained, because of the leveling is very important. The safety confinement of the base of the landfill, and the uh, proper layering, etc. Lines. I'll, I'll explain then. Operational aspects of the landfill, taking available area, the reception of the waste, and okay. In this picture, we can see that there is a reception area, the administration area, and inspection. How I already said for the manifestation procedure, and how to handle the waste, and how to they are actually discharging the waste in these trucks, and for daily basis they are actually managing all this waste, and when the daily process will end, they will use a kind of 20 centimeter laid clay layer, or covering soil to cover the land properly, because of that will evit the vector problems. Then there comes some rodenticide, like rat problems, or some birds problems. Birds, the migratory birds will come, and come there, and that will cause a serious damage, also problem to the human. And this is what we consider about this situation. A sanitary landfill formation, recovery project, burning gas and biogas storage, monitoring project, energy technical and environmental project of work complementary. Recovery project, like this is the sustainable part I already discussed, and like the gases. Some landfill they use methane gas burn system, like a flare, but they will not come to sufficient amount of methane to produce electricity. So biogas storage, in a bigger landfill, they will store the biogas, the methane gas. And the monitoring project, geometric, geotechnical, and environmental. The monitoring is very important, because of we have to monitor gas and the leachate water also, because of both these things will have the environment. So we have a proper monitoring wells at the base, at the surface of the landfill and the end of the landfill. Both the water flow will be, the water flow is very evident, that we need to consider the flow of water, if there any possibility to the water come in contact with the surface of the landfill, and inside the water table. And so we need a proper investigations adequately, and the engineers actually monitoring these things, the gas and the water wells, etc. Project of work complementary. That will comes for the future tax. Sanitary landfill operating procedures. This reception must be done for the entrance of the landfill. The procedure, and there is some procedures I have to operate. Landfill has a proper procedures. There is an entrance. The reception must be important to check out of what kind of waste, etc. The details of the trucks, etc. The truck must be weighed. There is a weighing machine, and to check every truck, what kind of how much waste inside the truck, etc. The truck must be inspected. The truck must be inspected, and the sample must be taken out for the laboratory technician for the studies. Which kind of is this any kind of harmful to the environment, etc. Optimization of human, material, and existing financials. That will comes for the elaboration of the project, what kind of cost will comes over, etc. From source utilization. From the resource utilization means there comes a lot of when a landfill under construction, we need to remove a lot of things, actually. Maybe a part of the environment, actually, we need to reconstruct. We need to remove a lot of huge amount of lands and soils, etc., and that we can reutilize for the cells, maybe the covering layer of the cells, etc. reuse. The waste must be inspected at the point of discharge. Yeah, that's very important because of if there are any kind of things actually occurs in the inspection area, we can there is some cameras and human efforts also to monitoring all the waste and allocation of the waste, etc. And soil can be material methane supply. Okay, the soil can be soil media can the areas from the excavation of the trenches. We can reuse the soil from the trenches, and the same trenches there will occur a lot of a huge amount of land, soil, etc. We can use you can reuse in it. Zoning of the disposal area of the waste according to its characters. The zoning we can zone waste. We can prepare like a different landfill we can construct, or I already told we need to construct a land with the less environmental pollution and less environmental problems with the human as well as the environment also. So zoning is very important according to the characteristics. And we can construct industrial waste with different places and domestic waste, etc. Different landfill ports we can construct like that. And closing and sealing of the landfill. And proper closing is very important because of a daily basis when we put all this waste in a particular 10 meter, 15 meter, etc. And we have a proper coverage of waste by closing the landfill daily basis. Geotechnical and environmental monitoring and geotechnical and environmental monitoring, final coverage, gas treatment and percolation, and periodic site inspection. Periodic site inspection is one of the very important because of in each and every there is a supervisor who inspect the inspections, maintenance, service, for installed equipments and accessories. There may need a lot of different equipments like compaction of the waste and how to manage properly. Otherwise, it will cause a serious problem. So we need a monitoring of the mass behaves of a central landfill, crossing and sealing according to the project. You guys have to see how it will come gradually in a landfill with a proper idea. You guys have to see the different cells and how they actually packed and covering materials, etc., covering, etc. And there is a perforation of a gas well, etc. And there is a flame, flare, and there is a fire, etc. You guys see, and there is a lot of different spots. Those are monitoring spots, etc. We can monitor the gas level and the leachate, etc. You can see, and there is different flyers that depends upon the size of the landfill. Maybe in some landfill, all these gases we can collect and prepare the sustainable energy like uh, electrical energy with the gas. Okay, this is one of the landfill has some aesthetic ideas actually, and when we consider landfill, we have a final idea how to reuse that amount that place, and we can make like different ideas like a playground because it's a very and natural friendly. We are actually uh, reconstruct our nature in that place also. So we have to plan. We need to proper maintenance. It's very important from that place also, and we can reconstruct like a football ground in this left side of the picture. You can see that, and the one of the idea, the Tel Aviv. That's one of an example. Tel Aviv transformed into world's largest recycling facility. And that's a landfill area, and they have to reconstruct it like a park, and it's a very interesting. And this is one of the biggest park. Actually, this is under construction, and it's in 2,200 acres. Fresh Kills Park. It will be. It comes in New York City, and it's 3 times size of the Central Park of New York. Also, and this is almost around 100-year project, and in 2036 it will be start the project. I think so. And this is one of the biggest landfill idea. And there is a lot of museums, parks. There are some different ideas, actually, aesthetic ideas. It comes in that park, and it's very big park. I think so. So one of the largest parks I ever exist in the managing landfill. I think so. And we have another sustainable part of energy production, because of this is a landfill site, and you guys seen there is a lot of solar panels actually allocated. After when we finalize a landfill, when we finish a landfill project, it's not easy. It will take almost around 10 years, maybe 20 years, depends on the size of the landfill. It will finalize. And we can see that a landfill is just like a hill. Actually, we construct it like a eco-friendly hills, some mountains or something, etc. And yeah, we can see all this. We can utilize all the spaces. Like this is one of the sustainable part of the energy we can see in this picture, like electrovoltaic cells, and that by thereby we can produce electricity. It's a great idea. It's in Ohio in United States. Okay, this is one of the statistics I already seen in this so far. And in this picture, 2018, 2014, and 2014, we have a comparison of three pictures. In from the right side to the very left, we can see other renewables, wind, solar panels, hydro, nuclears, CCUS, oil, natural gas, coal. And in this picture, we can see the amount of coal is 38% 2018 in this picture. And they are actually using the traditional system, and it can produce a lot of carbon dioxide, and that will cause greenhouse uh, problems, and there is a lot of environmental causes actually produced in this picture, you can see. And the 23 percentage of the coal and etc. And you guys can see in this picture. And when we comes in 2040, the sustainable side is tremendously increased, and the traditional energy side decreased. What we can compare in this picture, 4% of coal actually using in 2040. And all other things will be comes around other renewables, winds, solar panels, hydro. Nuclear is a little bit, but it mostly comes in renewable parts of energy, like wind, solar, etc. And CCUS are one of the measure. Actually, what is CCUS? It's carbon capture, utilization, and storage. Carbon capture, utilization, and storage is one of the technology we can implement across traditional plants, it's mainly comes around in oil and gas industry, and we can the production of electrical energy through oil and gas. We can establish the system, so we can reduce the carbon dioxide. The carbon dioxide gas we can carbon capture. The carbon we can capture and utilize and storage. We can this technology we are implementing across the traditional plant system, and this will collect all this carbon dioxide, and we can store in ships or pipelines, etc. And maybe we can convert this carbon dioxide into underwater storage or underground storage, and convert it into resources, etc. It's a very interesting thing also. Advantages of landfill. It's cheaper. It's very cheap alternative. Low capital investment, complete and definite method near the urban area. Recover the land. Works in a short time. General jobs, generate jobs, and generate energy. You can see all these advantages, and it's very beneficial. And in we are in like Kerala, it's very important, like in a landfill, because of we don't know how to manage. I'm also the part of society, so I can say that. But in these different countries like Europe, States, and Europe and South America, we can see different kind of landfills. I think we have some landfills out there in India, but sometimes its operating is somewhat not satisfactory. The disadvantages of the sanitary landfill: acquisition of land, It's some small disadvantages. It's also you can see acquisition of land. Maybe we need a huge place of land without any cost and trouble to the human and environment. And the construction and supervision, construction, operation, post-closure surveillance, a risk of transformation into the landfill. To the landfill, there is some risks actually in the earth. We have to remove a lot of huge amount of soil, and it depends upon the place, and it may cause some damage, some problem to our environment, etc. Possible water pollution, it might cause possible. There is a possibility. We have to prevent it like an impermeable layers. We are actually using different layers like already I told you, like primary and secondary impermeable layers. But some cases there occur some if we don't practice all these layers, then maybe it cause some serious water pollution and air pollution may occur. Maybe all this waste when while operating you have to arrange all this waste and it's not a proper manner, and there may cause air pollution, some debris, some what we call the particulate matters, etc. That comes to cause a little bit problems, etc. And why it is important is sanitary landfill. It's about problems and improves. It's very important actually. We can consider that our health and social, economic, ecological, environmental, aesthetic. I already all said about a complete picture about landfill, how it helps in health, and how it is important to the social, economic, ecological, environmental, aesthetics. Like a final recuperation of the landfill, we have to reconstruct it that in a form of a recreational parks and etc. Planning and design of a sanitary landfill. Selection of area, planning, how we have to plan and design of a central landfill. Selection of areas, it's very important. Selection that area will analyze due to the combination of engineers, like a geotechnical engineer will select the area and study, and there will be a study occur for a long time study actually. It may cost 6 months, etc. Collection of information of the project. Then we have to be collect all this information, how to build the process, engineering side of the project, general concept, executive project of landfill, and cost. Yeah, it might need somewhat cost. It's costly for the first concentration for concept, but for a particular year, it will not much cost. I think environmental impact assessment studies. An environmental engineer will carry out all these impact assessment studies, and like I did this job also. Plan of operation. Plan of operation mainly it's an operation. How we have to operate a landfill. Mainly, we need to consider delimitation of the spaces. So construction of cells. We have to construct like a small cells. I will explain to more specific later. But these cells, we need to construct each and every waste like cells, so we can use all the space very proper manner and with very little space arrangements, etc. Area trench frame, covering material. We can get all this covering material from the landfill also. Because we removed a lot of huge amount of soil, so we can use replace the soil like a covering material. Technology and control. Technology, we need some kind of technologies like volume of garbage, land, leachate, gases. We need to control all these things with technology. Okay. The maintenance of the machines, equipments. We need a proper machineries to maintain facilities, the monitoring and treatment, effluents. We need to a proper treatment of in any landfill. It's very evident that we need a water treatment plant, and we need to monitor. Adequate monitoring is very important because of if there any chance to cause our environment, etc. And security and emergency procedures, and proper security is needed because of if there a chance in some landfill there's seen some dead bodies, the parts of the bodies, etc. That will cause another problem because of if their truck will hide all these things and dump, and that will cause another problem. So we need to check out all this landfill and proper monitoring, a training program, and the people that manage the operational, they have some procedure how to operate inside the landfill. And so they are trained, and this is a training program we are giving them management and operational manual. There is a manual is important to operate all these things, etc. Quality control, quality very important. We need to control all the part while constructing a landfill, and each and every monitoring and all these different lineage like the layers. We have proper things. Actually, I didn't much explain about this, but lineage. All these lineage is very important. I already explained, I think. And quality control and gases like CO2, H2S, CH4, and carbon monoxide. Those are the gas actually produced in a landfill. A percolated liquids samples. So we need to collect the samples, and there is a study what kind of materials in it. Vectors like flies. There may cause it's area maybe cause a little bit smelly. Some smells actually occurs, and that will it cause for the rats that will attract rats and birds, etc. And we need an vector control also. And this is operational procedures. How we have to, while constructing the landfill base, we need a method. And this is the methodology we are using: trenching. And we firstly we prepare the trench and how to manage. We are constructing with. You can see that the orange color, orange sheet, is a cell. Is a cell of a particular cell of a waste cell, what we call. And the dark portion. Over the cell called covering material, and this way we can construct each and every cells, and there will monitoring what the gas monitoring system, you can see that, and proper pipelines, etc. You can construct in different constructional parts of the landfill. It will comes, and this is a ramping, and there is a construct like a little ramp, because in this ramp we can be very easily to pack up all this waste into the landfill, and this is a very confined way we can do all these things, etc. And cell types and measures. This is a proper cell. How we manage the cell. You guys have to see in this picture. There is a height of the cell. It's almost around 230 and advanced 20 centimeter. We are using like a cell covering, and in this triangle we can see a ratio 1:2. The height is might comes 1, and the base is 2, and the slope will be the ratio, etc. Will comes around. The volume of waste in our landfill, we have taken out 11.04 meter cubic, and the volume of the waste, and the volume of the covering material, what we call the soil, comes 1.46 meter cubic. And we can see in this picture all these measurements. The advancement of the landfill daily becomes 4.80 meter. It depends. Maybe the next picture you can see 6.2 meter, and the height is 2.5. It includes the covering material also, 2.3 plus 0.2 meter for the covering material, and the advancement of the cell 10 meter, etc. And this is a final structure. We guys have to see in this picture on how we have to manage with respect to all the engineering aspect, how we have to pack up all this waste with very confined manner, and how we construct all these waste, all these gas wells and the pipelines and the leachate pipeline system, etc. And there is a liquid storage, water treatment plant, and there is a electrical power plant also. We can see in this. This is the way we can take out a landfill in the form of a sustainable energy, etc. It's a very very good thing. And I would like to summarize this thing for this resume of for a video. What I'm working in the real environment stories and how we have to manage the waste, like a landfill and sustainable energy. You can see in this link. I think I will try to open if I can. Somebody who helped me. I think so. Okay, I will. Can I stop this? This is the final, but after the final, we can go to the next presentation. Mm.
Improving access to resources while preserving and replenishing those resources is what we do at Veolia. Each day we manage landfill sites for non-hazardous waste as they produce. By transforming this biogas into electricity and heat, we turn waste into a significant source of renewable energy.
Hello, Nidin.
Hello, Mony.
Hello. Is there any kind of disturbance actually the screen out there for playing this video?
Okay, 1 minute.
Would you manage it, please?
Okay, 1 minute.
Improving access to resources while preserving and replenishing those resources is what we do at Veolia. Each day we manage landfill sites for non-hazardous waste and collect the biogas they produce. By transforming this biogas into electricity and heat, we turn waste into a significant source of renewable energy. Here's how and why at a glance. Household and industrial waste that is not recycled or recovered elsewhere is brought to landfill site by truck. The waste is weighed and checked to make sure it is not dangerous in any way. It is then taken to a landfill cell. The design and location of these cells are thoroughly studied beforehand to make sure the environment is protected. Depending on the nature of the ground, the base and sides of each cell may be reinforced with an impermeable mineral layer. Then the cell is lined with watertight membranes to keep the waste mass contained. Waste is deposited in a cell in operation, then spread out and compacted. This operation is repeated, so the layers become increasingly dense as they accumulate. The rainwater that percolates through the waste forms a liquid known as leachate, which is drained off and treated. After a cell is filled to capacity, it is closed and covered with a layer of soil that is put into its natural surroundings. The cell's environmental impact monitored for several decades. Inside the airtight cell, an absence of oxygen causes the organic waste materials to ferment, a natural process that creates a large buildup of biogas, made up of a mixture of methane, carbon dioxide, nitrogen, and oxygen. This biogas is captured by a network of vertical and horizontal layers of waste. It can then be used in a local industrial process or conveyed to a cogeneration plant. Next, the biogas is purified before being burned to fuel combustion engines. The combustion heat pushes a set of pistons, which in turn drive an alternator. This alternator produces electricity. Some is used on site and the rest is delivered to the high-voltage national grid. Residual heat from combustion can be transferred by heat exchanger to a nearby district heating network or to an industrial or agricultural facility. Capturing and utilizing biogas from landfill waste means less methane is released into the atmosphere, so it contributes to combating climate change as well as preserving resources.
Okay. I just back to the presentation. I think our class is over, and you guys all enjoy the class. Thank you all, and thank you for listening me, for giving such an opportunity, and all of you who taken attention for this class. Thank you all.
Thank you, sir.
Hello. Okay.
So, participants, please note it's your time. If you have any doubts regarding the topic or some questions for Mr. Mony, please unmute yourself and ask, or else you can drop your questions in the comment box. So, participants, please.
Hello. Uh,
Okay.
Good evening, sir.
Come on.
Sir, my question
Good
is
evening.
that will solar power projects will produce more power than the electricity projects?
Yeah, there is possibility, but we need to manage the gas, the methane gas also. Thereby using we can both install all this managing the methane gas with electricity, as well as we can also use a solar power plant. And there is no problem at all. We can carry out that project. The aesthetic part will be converted like to a solar panel system also, and we have to connect all this production of electricity to connect to the grid, and we can use it.
Okay, sir. So my second question was, which soil is best for the landfill?
I didn't get the question. Would you please repeat?
Sir, actually, I was saying which soil is best for the landfill fertility.
Uh, Okay, I didn't get clear the question actually, because of we are it's a transformation of the soil. Actually, we are in landfill, a particular landfill. We have to remove a lot of soil actually, right? And this soil we are actually using for the covering of each and every cells. Do you understand? And that's fertile. Maybe it depends upon the site. We can choose different sites. We can reconstruct a non-fertile site also. Did you get that?
Yes, sir.
Okay, because of
And
we can take out a place like a very unfertile site. We can choose like a landfill and for any cultivation or another procedure, but we can replace it like a landfill, and thereby we can construct a very environmental aesthetic part also. Did you get that?
oh, yes, sir. Thank you, sir.
Thank you too. Is there anyone those who have any question around in this topic? I think hope you guys enjoy the class.
Yes, sir. Gratification. With utmost pleasure, I express my sincere gratitude to you, sir, for such a vivacious section and for joining us this evening. Now it's time for gratification, and I welcome Anjana Somasundran for vote of thanks.
Good evening, all. I deem it a great honor to propose vote of thanks to all who have helped us in making this webinar such a resounding success. First of all, a hearty vote of thanks to Mr. Mony Bernard, sir, project engineer at Veolia Environmental Services, Argentina, for he who had spent his busy schedule and valuable time with us, summing up something new to our knowledge. Thank you so much, sir, for your time and effort. It was really
Thank,
an interesting and meaningful session. Thank you, sir.
thank you
We
too.
would also like to grab this moment to mark our extreme gratitude towards Reverend Father John Paliekara, our Executive Director, Joint Director Father Joy Payapalli, our most beloved Principal Dr. Sajeev Johnson, Vice Principal V.D. Johnson, Chief Mentor Professor Prem Kumar Sir, and Triply Department HOD Benny Sir for their esteemed presence and motivational words in this webinar. Thank you all. We would also like to thank all department HODs, teaching and non-teaching staffs who had accepted our humble invitation to join with us. Special thanks to Staff Coordinator Nidin Sir and Jessel and Rajeshwari for your marvelous anchoring, and to all class coordinators without whom we couldn't accomplish this event. Last but not the least, we are all thanking to all the participants in the meet, as well as the YouTube viewers, for being a good listeners with a keen interest. Once again, thank you all, deep from our heart, Team Beta. Thank you all.
Everyone, please note that feedback link is available in the chat box. Please do fill it before you leave. So now we have come to the end of this webinar. A transition to clean energy is about making an investment in our future. So I once again express my heartfelt gratitude to all the participants for their active involvement, and special gratitude to all Argentinians. Thank you.
Thank you all.
Thank you, sir. Thank you all.
Thank you all.
Okay, thank you, Mony. Thank you for the wonderful session.
Thank you, Nitin.
Okay.
Thank you, sir. I am Benny.